Alright, we are back for some evening studying. This session, I'll be doing Calculus 2 homework for most of the time. There will be some topic review, but majority of the time will be spent problem solving. So, for this video, I'm going to try solving problems out loud and see how that does, if people like it or not. If it is not what people are looking for, we'll go back to studying quietly and making it a more normal study with me video. And with that, I'm going to open up the first assignment and we're going to get started. I just need to sign into the software the school uses. Which is Blackboard. So I'm taking Calculus 2 at Tulsa Community College. This particular assignment is titled Integration Strategies. So, not sure exactly what that's going to look like. Just loading in. All right. Okay, 20 problems. It looks like it's just going to be a mixture of integration strategies that you would learn in the first semester of a Calculus 1 course. So, first thing we're looking at is U substitution. What do we have here? Okay. So the integral from 0 to 2 of x squared times e to the power of x to the third dx. This is a pretty obvious way to proceed here if you're familiar with U substitution. I'm going to set u equal to x cubed. Du dx then would equal 3x squared, which then of course leaves us with du over 3 equals x squared dx. So I'm going to substitute that in, and we end up with integral from 0 to 2. It's a terrible integral sign. Of e to the u du over 3, and we're going to rewrite that as e to the u 1/3 du, which now obviously that becomes a pretty trivial integral. Oh. In this case, because we have a 1/3, I'm going to make sure we carry that out. So we have 1/3 e to the u, or e to the x third, and that's all from 0 to 2. So we'll have 1/3 e to the 2 cubed minus 1/3 e to the power of 0 cubed, which is just 0, which means we're going to end up with 1/3 times e to the 2 to the 3rd is 8. So e to the 8th minus 1/3. So e to the 0 is just 1. And we are going to type that in and see how we did. That is correct. So on to the next one. So we're looking at the integral of 4x sine 5x differentiated with respect to x. We're wanting to identify a strategy to start out with. I think integration by parts is probably a good place to start here. That's correct. Oh, and that is all we were asked to do, is identify how to start the question. So, moving on. X cubed over square root 64 minus x squared dx. Let's see what we're doing here. It looks like we have a general form here where we can do trig substitution. So we have x third over, we can write that as the square root of 8 squared minus x squared, where this is the general form a squared minus x squared, and we can sub in x equals a sine theta. Looks like that is one of our answer choices, x equals 8 sine theta. And that is correct. That's another question down. Moving on to question 4. Right. I should be labeling these as I go. Let me go up and do that real quick. Alright, question 4. You're going to identify a technique of integration for the following integral. So, we're looking at the integral of 5x squared plus 18x plus 20. And that's all over 2x plus 3 times x squared plus 4x plus 8. Now the first thing I'm thinking, because I have two things on the bottom, and I have a power, so if we multiply that out we'd get x cubed, or a degree that is higher on the bottom, which means the fraction is proper, which means we would probably have some success decomposing it into partial fractions, and that is correct, so that would be the correct approach. Let's see if we start doing that approach, or nope, just identifying it. On to the next problem. Right, question 5. Now we're evaluating an integral. Okay. We're evaluating the integral of sine squared of 34x dx. Alright. Now here is where having a cheat sheet of integration formulas can be pretty handy. Unfortunately, I don't have those on hand because screen sharing with the tablet, and they are on my tablet. So those are not available to me. Unless okay. Going to move this, move that, and you're good to go. So you just saw my other browser, with my how to start a YouTube channel tabs. I am new, don't blame me. Now I have my basic integration formula sheet in front of me, just because I don't have all of the formulas memorized yet. There are a lot of them. But what we're sort of interested in here is breaking up the sine squared, or breaking it up into as angles, right? So one thing we can do with sine squared of x is turn it to 1 minus cosine 2x over 2. That is a power reduction formula. So we're actually going to give that a try. So we'll have 1 minus cosine 2x here. We already have 34x, so that'll be 68x. And that'll all be over 2 dx. And now this becomes a super trivial integral, because what we can do, well, it might be, is turn it into 1/2 times integral 1 minus cosine 68x dx. Yeah, and then we're looking at 1/2 integral 1 dx minus 1/2 integral cosine 68x dx. And that's looking a lot nicer. But my family has just brought food home, and I am needed to help carry it in. So we are going to be put on break. Not that I ever clicked off the starting screen. Alright, done carrying food in, but I am going to have dinner with my family. Studying is important. Eating with your loved ones is even more important. So I am going to click back on to a 15-minute session. Hopefully I'll be back by then, but it's to keep you guys on the regular schedule. So I'm going to leave you guys to yourselves. Try not to misbehave. Alright, I am back. Dinner was great, but it looks like I'm gonna have to work through the break. Alright. Break time is a good time to get up, stretch your legs, get some water, a snack, or to doodle. Doodling kind of helps your mind relax, but it also helps you stay focused, or rather, recover better so that you'll be able to focus during our next 50-minute work session a bit better. So I'm personally, even though I've been gone for most of the session, I'm going to do some doodling. And you shouldn't check your texts, but I'm going to do that as well. Epic fail, spelling doodle. got a little distracted drawing and ran over time, but that's a good thing. You should be enjoying the process. So we're going to go ahead and jump into our next work session. Another 50 minutes of studying. Here goes. Okay, so we made an error. Now we have to correct this entire integral. It's a bit of a long one. So, let's start from the top. We're taking integral notifications. Turn this off. From 0 to pi over 6 of secant x plus cosine x squared dx. So let's expand the integrand really quickly. That's going to give us secant squared x. Secant times cosine x plus cosine times secant x is just going to be 2 secant x cosine x plus cosine squared x. And then we're just going to go ahead and separate out those integrals. So we'll have the integral from 0 to pi over 6 of secant squared x dx plus the integral from 0 to pi over 6 of 2 secant x cosine x. We'll write the x more clearly. Dx plus the integral from 0 to pi over 6 of cosine squared x dx. Alright, now what do we do with these? Well, secant squared x, that integral, is a common one that's just going to be tangent x. So that's just a rule that you know. And we'll put our limits of integration there, so we know to go back and compute it. Now, secant x times cosine x, that's interesting because secant x is equal to 1 over cosine x. That times cosine x is just 1. So we have 2 times 1. What we really have is 2. The integral of 2 is 2x. So we have 2x from pi over 6 to 0, and then finally we have the integral of cosine squared x. Now here we're going to use one of our half angle formulas. So cosine squared x is equal to 1 plus cosine 2x over 2. And again, that's integral from 0 to pi over 6 dx. Wonderful. Alright, so let's compute these over here really quickly. We're going to have tangent of pi over 6 minus tangent to 0 plus 2 pi over 6 minus 2 times 0. We're going to bracket those off to know that they are independent arguments. And then this integral right here, this last one, what we're going to do is we're going to split it up. We're going to get integral from 0 to pi over 6 of 1/2 dx plus the integral from pi over 6, or 0 to pi over 6 of 1/2 cosine 2x dx. Right? So tangent to pi over 6, that's 1 over square root 3. That's not something I knew off the top of my head, I had to look that up. Minus tangent of 0 is 0, plus 2 pi over 6 is just pi over 3. Right? And then minus 0. So again, I'm going to block that off. Plus, we have 1/2 x is going to be this integral right here, and then we know that's going to be 1/2 pi over 6 minus 1/2 0 plus the integral of cosine some value a times x, where a is, I'm just going to say a real number. You don't need to worry about the technicalities too much right now, because we're not going to get any integrals where that is something we need to identify. But we should know that that integral comes out to 1 over a sine of a of x. So we're going to end up with 1/2 of, because we're just going to assume we've taken this 1/2 outside the integral right here. 1/2 sine of 2 times x, the first being pi over 6, so it's just pi over 3 minus 1/2 sine 0. Now, fairly sure, if I remember my trig right, the sine 0 is 0, right? That is correct, so we can cross that out. Now we're also going to cross out the other 0 terms and bring them down. So we have 1 over square root 3 plus pi over 3 plus pi over 12 right here. That's from this term, plus 1/4 sine pi over 3. Now, the exact value of sine pi over 3, that is going to be 0. Really? Yeah, no, it's a lie. Pi over 3, as I thought, square root 3 over 2. Okay, I just wanted to be sure. That's why you always scroll down when you Google something. So we have 1/4, combining these two 1/2s, and then sine pi over 3 is square root 3 over 2. Okay, so at the end of the day, we have 1 over square root 3 plus pi over 3 and pi over 12. We really want to combine those. If we multiply the top and bottom by 4, we'd have 12. So 4 times 3 is 12. So we'll just take 4 times pi. We have 4 pi over 12 plus pi over 12. That's 5 pi over 12. We're going to write there. Plus, this is going to be square root 3 over 8. And let's get all of this factored together. Now, 1 over square root 3 plus square root 3 over 8. What we're going to do is multiply the numerators and denominators together. So we'll have square root 3 times square root 3 and 8 times 1. So 8 plus 3 over 8 square root 3, which is just 11 over square root 3, plus, don't forget our third term, 5 pi over 12. And let's just go ahead and make it into a superfraction and combine all of it. I've lost connection to my screen share. Let me reconnect that. Alright, we're back. Alright, let's do the last bit of combining. 12 times 11, that's 120, 132, plus 8 square root 3 times 5 pi, that's 40 pi square root 3, all over 12 times 8, it's 96. 96 square root 3. Assuming no silly errors in algebra, that should be the correct answer. Let's see how that works out. sure you guys know, more often than not, unfortunately, silly math errors do happen. So, because this answer is so funky looking, I am kind of expecting one. Six square root 3. Alright, that is the expression. And that is correct. Awesome. Trust the math. Very good. So we are on to question 7. Alright. We're taking the indefinite integral of 8 times e to the x over the square root of 81 minus e to the 2x. Okay. So right away, it looks like a little bit of u substitution is going to take us straight to the form that we are looking for, to do some trig substitution. And that's something you just have to do by practicing problems, and you'll get experience spotting those. Not to say that I am very experienced by any means, but let's go ahead and give this a shot. Okay, so we should have u equals e to the x, and du equals e to the x dx, which is awesome because both of those values are in here, and that will leave us with, we'll take the 8 out, 1 over square root 9 squared. You'll see why I do that in just a second. And this is u squared. E to the 2x is the same thing as e to the x squared. So that's u squared du. It's awesome because in equations of the form a squared minus u squared, we can substitute u for a sine theta. So in this case, u equals 9 sine theta. And you'll see why that's helpful in just a moment. So 8 times the integral of 9 squared minus 9 squared sine squared theta. Basically just, since u is 9 sine theta, and we have a u in here, we're just, squaring both of the terms. Now, because we're doing another substitution, u equals 9 sine theta, we have to do du d theta and get the new derivative that the new marker for what we are taking the integral with respect to. In this case, we're switching over to theta since we're doing a trigonometric substitution. So du d theta, the derivative of sine theta is cosine theta. So we're just going to be looking at 9 cosine theta. So du over 9 cosine theta equals d theta. But we have a du in there, so really what we want is d theta times 9 cosine theta equals du. So let's go ahead and pop in our 9 cosine theta d theta, and in this square root, I'm going to do some work out here. We want to take the 9 squared out, and we'll end up with 1 minus sine squared theta. And what that's going to end up looking like is 9 squared cosine squared theta from the inequality sine squared, or 1 minus sine squared equals cosine squared theta, because sine squared plus cosine squared equals 1. Right? Rearranging a very simple identity in trigonometry. Now all of this is square rooted. In trigonometric substitution sets bounds, right, on the theta that your substitution is well defined for. And in this case, whenever we are substituting in sine theta, we are doing it for positive values, which is why instead of writing plus and minus, we're just going to say that this is equal to 9 cosine theta, right? So we end up with 9 cosine theta over 9 cosine theta, or 8 times the integral of 1 d theta, which is 8 theta. But what does theta equal? Right, so going back up here, theta is equal to u over 9, the inverse sine of u over 9. And what does u equal? E to the x. So it's equal to the inverse sine of e to the x over 9, right? Substituting back in the values that we had placeholders for. So this ends up being 8 times arc sine of the argument e to the x over 9 plus our integration constant c. And let's see how we did. Awesome, that is correct. So moving on to question 8. Question 8, we're taking the definite integral from 0 to pi over 2 of cosine to the 9th x dx. Now, in this case, we're probably interested in using some power reduction formulas. So power reduction formulas, again, not something I have memorized, but something that I am going to pull up on one of my monitors while I bring screen sharing back into focus. Right. So power reduction formulas are a really powerful tool for dealing with higher order cosines and sines, as well as tangents and secants. Right, so here's our formula for cosine. The integral of cosine to the n of x dx is equal to cosine to the n minus 1 x sine x over n plus n minus 1 over n of cosine n minus 2 x dx. As you can probably already tell, we are going to use this formula recursively to keep knocking down the power of the cosine. And there may be more efficient ways to take this integral, but I am relatively novice with these kinds of integrals that aren't being directly applied to physics. So I'm going to take this more roundabout approach. So the integral from pi over 2 to 0 to pi over 2 rather, of cosine to the 9th x dx is equal to cosine to the 8th x sine x over 9 plus 8/9 integral, it's kind of an ugly integral sign, cosine 7x dx. And now we're going to do what I said before, which is move this kind of to the left side of our screen and repeat that formula recursively until we get down to a super simple integrand that we can evaluate without any tricks. Right? So we have 8 over 9 times the integral cosine 7x dx, which is really 8/9 times cosine 6x sine x over 7 plus n minus 1 6 over 7 integral cosine 5x dx, which really is 8/9 times cosine 6x sine x over 7 plus 6/7 times, this is getting a bit messy, cosine 4th x sine x over 5 plus 4/5 cosine cubed x dx. Now, the end is near. We're going to do this long process one more time, and we are going to end up with a super pretty integral. Cosine, and we're going to bring down the stuff from before, cosine 8x sine x over 9 plus 8 over 9 times cosine 6x sine x over 7 plus 6/7 times cosine 4x, or cosine to the 4th power of x times sine x over 5 plus 4/5 times cosine squared x sine x over 3 plus 2/3 integral cosine x dx. Close all three brackets. Now, this disgusting large function is relatively simple to evaluate now. So let's start from the inside. The integral of cosine x is sine x. So we have cosine squared x sine x over 3 plus 2 sine x over 3. And we can eliminate that plus sign and just bridge them and put that plus in the numerator. Since they have the same denominator, they can be added in that way. And then let's apply the 4/5. So we'll put a 4 up top and then a 15 down bottom. So now we're evaluating 6 over 7 times cosine 4x sine x over 5 plus 4, let's move this down a little bit. I underestimated how much space I would need. As is typical with these kinds of gross large problems. 4 times cosine squared x sine x plus 2 sine x yeesh over 15. Really quickly, we're just going to do a change of base on this one. If we multiply the numerator and denominator by 3, we can add these two terms. So you're going to say 3 cosine to the 4th x sine x over 15 plus this, which means we can bridge this, write our plus sign up here, and put this all together over 15. Oh gosh, this is getting nasty. That is going to yield 18 cosine 4th x sine x plus 6, 12, 24. 24 cosine squared x sine x plus 48 sine x all over, I'm just going to leave it as 7 times 15.
When are you going to be done?
Hold on. Alright, now that we have that kind of gross fraction computed, I'm going to go ahead and take that. We're going to move it down. And we have cosine 6x sine x over 7 plus this. Excuse me. And we can see very clearly that if we multiply the top and bottom by 15, that we'll be able to add the two together. So I am just going to what's happened? Let me move this back down. So we're going to rewrite that plus up here, put that all over 7 times 15. Now, of course, this is going to be all times 8 over 9, which is frankly gross. At this point, it's very gross, but gotta do it. So what I'm going to go ahead and do is simplify this numerator, though. It looks like our smallest common factor is going to be a 3, the 3 sine x. It's 3 sine x times 5 cosine 6x plus 6 cosine 4th x plus 8 cosine squared x plus, it's 30 plus 18, 5, 11, it looks like. No, couldn't be. What is 48 divided by 3? 16. There we go. I don't know why I was blanking on that. Okay. Let's simplify that so that we have 8 over 9 times this expression, which is much nicer, because then we can put 8 up top, and 8 times 3 is 24, and 9 down bottom, and I'm again going to keep it separate because we have cosine 8x sine x over 9, and it's clear that if we multiply it by 7 times 15, then we can do what we've wanted to do, which is put plus, put this all over one common denominator, and now for the gruesome work of simplifying. Right. So first order of business, we have a 7 times 15 in front of our first term. And we need to see if that expression is divisible by 24. It is not. If it is divisible by 3, it is. By 6, it is not. I'm going to stick with 3. Okay. So 3 sine x times 35 cosine 8x plus 24 sine x, 5 cosine 6x plus 6 cosine 4x plus 8 cosine squared x plus 16 all over 9 times 7 times 5 times 3. We're going to split up that term so we can start doing some more simplification. So the first thing we're going to do is we're going to cancel this 3 with this 3, and then this 24, which will leave us with 8. So we have sine x 35 cosine 8x plus 8 sine x, 5 cosine 6x plus 6 cosine 4th x plus 8 cosine squared x plus 16. Still pretty nasty. So we have 3 numbers here, and we're going to see if we can take any more out of this. There are no common denominators or common multiples left in this parentheses right here. That appears to be the case, which is unfortunate. In this other side, though, we could take out a 5. So 5 times 7 is 35. However, it isn't going to simplify much because both of those terms are odd and prime, and we can't simplify the 8 sine x that we have out here. So that looks like it's going to be no dice. However, I want to check and see. Yeah, no, there isn't a pretty way to proceed with this. However, I think I am going to go ahead and rewrite as sine x 5 cosine 8x plus 8 over 7 sine x 5 cosine 6x plus 6 cosine 4th x plus 8 cosine squared x plus 16 all over 9 times 5, which is 45. And obviously this is plus c. This is gross and huge. So I have a strong suspicion that it's not right. But with 10 seconds on the clock, we are going to type this monstrosity out and see if we get some points. Honestly, if it does, this probably, almost definitely, is not the simplified form. And that is something that I am pretty bad about, is writing things in far from simplified form. X plus 16 up top, then down bottom, 45, 9 times 5, all plus C. Yeah, and unfortunately, that is incorrect, and it was incredibly time consuming. The smarter thing here is probably to use sines and cosines. And now that I'm thinking of that, I'm realizing that would have been much faster than using power reduction formula. But we live and we learn. I should have gotten the right results, but I probably made some algebraic errors. In any case, it is time to pack it in for the night. It's almost 11 o'clock. So, need to get some sleep so we can hop back on tomorrow and keep studying. That is going to conclude the final stream of the day. Good luck, everyone, with your own studies, and have a wonderful night. We'll see you tomorrow.